続いてのセッションはパルトナーさんによる、セッションです。
こんばんは、皆さん。はじめまして。私はダナです。So in here, I would like to talk about Earth as our canvas with our core Geospatial API. Yeah, let's get started. So, but before that, let's take a look about these AR core improvements. As you can see, AR core has a lot of improvements in terms of a lot of stuff. First, in terms of immersion, AR core has a level up about motion tracking, depth, and also dual camera depth. And of course, there is a new feature called a long range depth, but I will not talk about that in this talk. And then in other terms about augmentation, the plane detection has also leveled up. And in terms of word annotation, there's a new feature called Geospatial API, and that's topic that will be what I think that I will talk about. So yeah, so what is Geospatial API? As you can see from the name geospatial, geo means geography location, which has a x and y points, and then the spatial is a space context awareness, which has a z points. So when we combine those words, which is actually geospatial, it means that actually we got a context of space awareness in terms of location. So it's not just x and y, but also z. So in that case, in our AR core session, it's not only latitude or longitude, but also the altitude, like the height of a 3D model or the height of our location, whether we are on the mountain or maybe on bottom of the mountain. This API can understand that, which is really awesome. So with this API, it provides a lot of information. First, like for example, the latitude, and as well as the accuracy, and then the altitude, like the height, how high we are far from the ground, and also heading, like which direction we are heading, and as well as the rotation also. So this API is really great for determining where is our position because it has a lot of improvements in terms of accuracy. So with this API, there are a lot of use case like what application that we can apply. So in this case, for example, we can make a use of this API to park our bike to decide whether the user has returned their e-bike or e-scooter into the right place or not. And then this API can also provide a hack so that we can put a 3D model maybe on top of building or maybe around the building like this, or maybe we can make a game like jumping from one building to another building. So this AR core capability is really has a lot of improvements. It's not just like detecting planes or detecting like the surface or the marker of the camera, but this actually on a world global scale where actually position and also accuracy is really involved. So in that case, we can actually draw AR anywhere because we can make a use of the position of the location and also with the Google Maps function inside this AR core, we can like literally put our AR or 3D model everywhere around the globe. And also that could be integrated where each user aware of the other interaction of the AR with the simple implementation of Firebase using Firestore maybe. So to make us more understand about this API, let's watch this video first. Wow. As what the video stated, it says that we can create everything like we see our art as our canvas, which means that we can create everything everywhere and for everyone, which is awesome. So the big question is how this API is made, how this technology is made. As we can see, first, users send device, magnetometer, and camera sensor, the functionality like the user sending the geographic position, like using GPS, and also track the image that they are using with their camera. Those sending process is called visual localization. It's a real-time alignment of tracked image with a localized image. But localized map, what is that? It's a map that produced from global localization that I will talk about that later. So first, user performing visual localization, like sending their GPS location and as well as the picture that they are tracking into the API. And then this API will perform initiation of visual localization into a Google VPS or called Visual Positioning Service. And it will only like it took less than 1 second to have a response, a more accurate position. And since because the VPS are using Google Machine Learning Accelerator TPU, and then after that Google will provide a more accurate position, and user will get a more accurate position as well. It's not just X, Y, but also Z, like the H of the 3D model. But the question is that what is VPS? So this VPS or Visual Positioning Service is a service that provides a more accurate position based on the visual, based on the tracked image that the user sent to the service. So in this case, visual localization has been requested, sending the geographic position and tracked image. And then those two things will be matched with the 3D high resolution data inside Google. It's a data that represents 3D context awareness in the form of localized map that has been processed by doing global localization. And then it will have a response of visual localization response, which is actually a more accurate position. So this 3D high resolution data is performed by a global localization. So this global localization is a process of doing a map localization. It's a process of understanding to get the 3D points in a certain image. So as you can see, Google has a billions of 360 images that are collected for more than 15 years. And that picture is saved in the database of Google Street View. So this global localization is a process of map localization of performing a process for all of those images in the database. And all of those images will be processed and will have a lot of 3D points data, which is trillions of 3D points that Google has been made from those pictures. So this map localization is a process of turning 10 billions of street image view image into trillion of 3D points. So as we can see in here, for example, one of 360 image that has been captured, and then the Google will compare and get the similarity of 3D points to decide where actually the user position is. So in terms of GPS, but Google in this API is also provide a more accurate position based on the image that has been tracked of the user. So as you can see from this point, global localization has a lot of benefits in terms of many aspects, starting from global scale coverage, precise location, precise orientation, remote placement, and location guidance. And as you can see, if we only use like a usual GPS, or maybe we are using AR cloud anchors, global localization has a perfect performance in terms of everything. So I think this is really a great improvement that we can try. And then let's take a sneak peek in the Knut snippets. So basically, actually, it's really simple to implement this API. First, you can try like clone the sample project that Google Air has been provided in the link, and then after that, in the current repository, you can replace the API key. Don't forget to activate it in the Google Cloud project and get those API key by enabling AR Core API and also enabling Maps SDK for Android in your Google Cloud project. And then in the example project, you will find a Hello Gear activity, which means in this file, you can enable the geospatial mode because in the default it's a disabled, so you can enable that by doing some configuration, applying some configuration for the geospatial mode. In this case, it will track the image that we will send to the VPS also. And then in the file of Hello Gear renderer, you can try to get the properties. You will have a properties of Earth in here, and then inside the Earth, you can have all those information, like for example, the latitude, longitude, where is are heading, and also as well as the orientation or maybe the height, like the altitude. So you will got a lot of richer information that you got from this API, aside from only usual GPS, but you have a lot of other information that you can make a use for many kind of application in your AR. So the limitation on your AR will be really immersive and really unlimited. So in that case, we can make a lot of many kind of application, maybe like integrated online AR experience that can be accessed by anyone or maybe anywhere. You can, like for example, make use of this to park a bike or our vehicles in order to provide a more accuracy of the position. As you can see in here, it's marking really precise exactly in here because it's also using a VPS service. The height and also the terrain, everything will be considered in the VPS and provide a more accurate position. I think that's it from me, and arigato gozaimashita.
パラダナさん、ありがとうございました。ただいまより5分間の休憩とさせていただきます。次のセッションは17時30分から再開します。